Hello everyone. Today we are going to cover the problem solving part of chapter number 12. Let us start. So our very first problem is about net present value. Here you can see we have specific date and we know the cash flows in each of those dates. And then we also know our discount rate. Our discount rate here is 11%. And then because we have a specific date here, therefore, to calculate NPV, the formula we are going to use here is XNPV. XNPV, so here you're going to choose the rate you have here, it is 11%. And then here, you're going to select all the cash flows you have over the life of the project. Then close the bracket, hit enter. Oh, after values, you need to put the dates and then hit enter. So then you get your net present value. Now you can see here, the net present value here is positive. So we are going to here add value to the firm. So if you add value to the firm, then you should accept the project. So decision should be accept. All right. Next, in the next problem, we are going to calculate the payback period. And you know what is payback period. Payback period is the number of years it is going to take for you to recover your initial investment. Now here you can see your benchmark payback period is 3. That means you want to get your money back under 3 years. If you get your money back after 3 years of your initial investment, then you're going to reject the project. All right. So now let us calculate our payback period. To calculate our payback period, let us first copy all of our cash flows to our payback period table. Then you're going to calculate your accumulated cash flows. In the very first year, your accumulated cash flow should be equal to your cash flow in that particular year. In the following years, you should add your cash flow in a particular year with the accumulated cash flow in the previous year to get your accumulated cash flow in the current year. So let us apply. So accumulated cash flow in the previous year plus your cash flow in the current year. So this is how you should continue in all the other years. Now let us calculate our payback period. So according to the formula, it should be years before full recovery. So you can see here, you recover your initial investment in year number 4. So the year before full recovery is year number 3. So year number 3 plus unrecovered cost at the beginning of the full recovery year. So you can see here, at the beginning of the full recovery year 4, you still have $1,000 left to be recovered. So absolute value of our unrecovered amount over our cash flow in the full recovery year, which is $17,000. Hit enter. So you can see here, in this case, you are going to get your money back in 3.06 years. So here you should reject the project. Now, the next problem is a discounted payback period. So in this case, again, here we calculate the number of years it is going to take for you to recover your initial investment based on discounted cash flows. Now, in this case, our benchmark period is 3.5. That means we want to get our money back under 3.5 years based on the discounted cash flows. All right. Now let us calculate our discounted payback period. To do so, copy all the cash flows to the discounted payback period table. Then calculate your discounted cash flows. So to do so, we are going to use the PV formula, present value. Then your rate should remain the same in every single period. Then number of period. So here your number of period is 0. So you get this particular cash flow in the current year. So that is your N power. Next, your PMT. Here you don't have any PMT here. PMT means the periodic payment which actually recurs at finite time interval. But here you don't have any such cash flows which is repetitive and at the same time equal over the life of the project. So your PMT here is 0. Next, your future value. So you want to calculate present value of your cash flow. So your future value here is your cash flow. So in this way, you're going to get the value of your cash flow in the future years in the current time. Then close the bracket, hit enter. Do the same calculation for every other years. You can see here in period number 1, again, your rate remains the same, 10%. And then your N power is 1. That means you are getting this money in period number 1. And then your periodic payment is 0 because you don't have any recurring and equal payment here. You just have one lump sum payment, and that lump sum payment happens at the end of year number 1. So here, therefore, your future value is your cash flow. Hit enter. So this is how we should continue. So now we know the discounted cash flows for our project. Now let us calculate accumulated discounted cash flows. Like before, our accumulated discounted cash flows in the very first year should be equal to our discounted cash flow in the very initial year. In the later years, your accumulated discounted cash flows is equal to accumulated discounted cash flows in the previous year plus your discounted cash flow in the current year. This is how you should continue in every other years. So now we can see here, your accumulated cash flow turns into positive in year number 4. It means based on your discounted cash flows, you are recovering your initial cost in year number 4. So now let us calculate our discounted payback period. So it is equal to years before full recovery, which is 3 plus absolute value of our unrecovered balance at the beginning of the full recovery year over our discounted cash flows in the full recovery year. So now we can see here again, your discounted payback period here is 3.53. So it is little bit over your benchmark payback period. So in this case, therefore, your decision should be reject. Now IRR. So here we have the cash flows and we have the time period over which we are expected to receive these cash flows. Now to get IRR, apply the IRR formula in Excel and then select all the cash flows from the very first year to the very last year. So here your IRR is 24.01%. So this is the expected return from your particular project. But here your minimum required rate of return is 12%. That means you are getting the return over your required rate of return. So you are actually getting profit. In this case, your decision should be accept. However, if your IRR is less than your required rate of return, then the decision should be reject. Now, next problem. In the next problem here, you can see now we have a specific date and then we have the cash flows corresponding to each of those dates. Now to get IRR here, we are going to apply the XIRR formula. So here we have to first choose all the cash flows and then all the dates, then hit enter, then you get your IRR. Again, your IRR is 33.36%, which is greater than your minimum required rate of return. So the decision should be accept. Now, MIRR. So now in the next problem, you can see here we have more than one negative cash flows. Therefore, it is a unconventional cash flow problem. So for unconventional cash flows, you cannot apply the regular IRR formula. You need to apply modified internal rate of return formula. So let us do so. So for MIRR, the formula should be MIRR. Then select all the cash flows you expect to receive over the life of the project. Then your financing rate. Financing rate means your discount rate at which you finance your investment, and then your reinvestment rate, then hit enter. If you don't know your reinvestment rate, but you know just your discount rate, then assume that your discount rate is equal to your reinvestment rate. This is very important for your exam. All right, now here your MIRR is 14.82%, which is greater than the required rate of return. So again, your decision should be accept. Now, mutually exclusive project. So for mutually exclusive project, you know it is a either or problem. That means you can choose either investment A or investment B, not both. So let us calculate NPV and IRR for both of the projects individually. NPV, rate, then all the values. Here you can see we don't know a specific date here, we just know the time period, right? So in this case, you are gonna put only future cash flows inside the NPV formula. You don't want to put the current year cash flow inside the NPV formula. Remember that. But whenever you apply X NPV formula, then yes, you can put all the cash flows starting from the current time period to the future time period inside the X NPV formula. All right, the NPV of the future cash flows plus your current year cash flow. Again, NPV, your rate, all of your future cash flows inside the NPV formula plus your cash flow in the current year. Next, IRR. Again, IRR. Now here you can see your NPV and IRR for project number A are greater than those in project number B. So of course, for mutually exclusive project, you are gonna invest all of your money in investment A. All right. Now let us calculate the crossover rate. The crossover rate at which you will be indifferent between investment A and investment B. To do so, you first have to calculate your incremental cash flow. So here you can see the way I calculated here is I make sure here I just have one negative cash flow so that I can apply IRR formula. But if you happen to have more than one negative cash flows, then apply MIRR formula to get your crossover rate. So here you can see if I take the difference between investment B and investment A, then I get just one negative cash flow. However, if I choose to take the difference between investment A cash flow to investment B cash flow, then I'm going to have multiple negative cash flows. So I intentionally choose to take the difference between investment B cash flows and investment A cash, so that I just get a conventional cash flow. Now I have my conventional cash flow, therefore I can apply the IRR for. Now crossover rate here is 9.36%. So at this rate, you are indifferent between investment A and investment B. The very last problem is profitability. All right, so profitability index is the dollar return you get for every dollar investment in a particular project. And then the investment, the decision criteria here is you are gonna accept a project if your profitability index is greater than 1. And if it is less than 1, then you are gonna reject the project, right? So NPV rate, all the future cash flows over absolute value of your initial investment. Hit enter. Your profitability index in this case is 1.35, which is greater than 1. So the decision should be accept. That's all for today. Thank you.